Hello students. So today's topic of discussion is chain rule of derivative. A chain rule of derivative, why we'll use this chain rule or how the rule is used. So we will discuss in this video lecture. So the first question is, if suppose y equals to x plus 1 is given to you. When I say that differentiate this, so you can simply differentiate that dy by dx. Here differentiation of x is 1 plus differentiation of 1 is a constant derivative is 0, so the answer is 1. So we can simply say that the differentiation of y equals to x plus 1, so the differentiation of dy by dx for y equals to x plus 1 is 1. Okay, very simple. If I say that your y is x plus 1 whole square, so now find dy by dx. So most of the students will do like this. First of all, we will expand this, that is x square plus 2x plus 1 by using the a plus b whole square formula. Then we find the dy by dx. X square derivative is 2x. For this 2x term, 2 is a constant, we will write 2. X derivative is 1, so we will write only 1. And 1 is a constant derivative is 0. That is finally 2x plus 2. Okay. So suppose if I say to the power 10. Now it's not possible to expand x plus 1 to the power 10. We can, but during the exam it's not possible to expand this. Or if I say 100, so for that here the chain rule is used. What will do basically, you will find this type of questions like this thing, or we can say suppose e to the power 5x plus 3, or we can say log of x square plus a square. These type of things you will find here for differentiating. So what we have to do, suppose for this example only I'm saying, suppose we have y equals to x plus 1 to the power 100. So there is two things, you will remember one thing here. Another first thing is the bracket term x plus 1, and the second thing is the power 100. So always you will take, if you will introduce a new variable, here we introduce a new variable u. How we introduce? We suppose let u equals to x plus 1. So then the new form of y is like that, y equals to x plus 1. We have assumed x plus 1 as u, so we will write u to the power 100. So our always a target will be to convert the given question into a known form. Known form means, see, this is the form of u to the power 100. That means this is, we can say that similar to the form x to the power n power, and we know the formula of derivative for this thing, so we can use that here. So always our target will be to convert the given question into a known form. So how we'll differentiate this thing? So we will write dy by dx, that is ddx of u to the power 100. Okay, so now first of all we will differentiate for the power. What is the power here? 100. So first of all we go for the power. What is the formula for the power? We know that ddx of x to the power n is n x to the power n minus 1. We'll use this, that is 100 u to the power 100 minus 1. See, we have used the same formula just for the formula for the power. But one thing we have noticed here we are differentiating x with respect to x. That's why we have stopped up to this step only. But here we are differentiating u with respect to x. Here these two things x are same, that's why we have stopped here. But here this is u, this is x, these two are not same, so we have to further differentiate u with respect to x. So whenever we will see that we are differentiating a function with respect to another function, but that two functions are not same, then we have to further differentiate that particular function. Got my point? So whenever you see that the differentiating function is not same with respect to which it is going to be differentiate, then we have to further differentiate that particular function. So here we have to further differentiate u. Now just putting the value of u, we have assumed u as x plus 1. So we will write in place of u x plus 1, 100 minus 1, that is 99, d dx of u is x plus 1, that is we can write 100 x plus 1 to the power 99. And now differentiation of d dx of x plus 1, d dx of x plus 1, d dx of x is 1, d dx of 1, that is a constant derivative, is 0. So finally 100 x plus 1 to the power 99, this is the answer. So this is the way to differentiate whenever two types of things we will find in a given question. One is your bracket term, another one is the power term. Simply we will assume the bracket term as a new variable u and will proceed differentiation. So this is, here we have used the chain rule. This particular step introduce the chain rule. So this is all about the chain rule. Now we will solve some more questions on this particular topic. So let's start solving some questions. Okay, the question is y equals to 2x minus 5 to the power 6. So same like the previous one example, we will introduce a new variable. First of all, we will write let u equals to 2x minus 5. So then your new form of y is y equals to u to the power 6. So now we will write differentiating both sides with respect to x. So your this side will be dy by dx, this side will be d dx of u to the power 6. Now power means x to the power n, same formula, that is the formula is n x to the power n minus 1. It's me here 6 u to the power 6 minus 1. Now again this is u, this is x, they are not same, so we will further differentiate u with respect to x, that is we will again differentiate u with respect to x. Now putting the value of u, what was the u here? 2x minus 5, 6 minus 1, that is 5, d dx of u is 2x minus 5, that is 6, 2x minus 5 to the power 5. Here is two term, that is first term d dx of 2x minus d dx of 5. 6, 2x minus 5 to the power 5. Now see here 2x, okay, 2 is a constant. Again we know the constant come after the derivative, that is 2 only, and x derivative is 1, minus 5 is a constant number, constant derivative is 0. So 2 into 1, 2, minus 0, that is finally this term will give 2, and 2 into 6, 12. So your final answer will be 12, 2x minus 5 to the power 5. Clear? So this is the way to use the chain rule. Very simple method and very useful for further differentiating more advanced type questions. So let us proceed to the question number 2. So this is question number 2. You can just see the question number 2. I will not solve this question. You will try this question. This is like similar like the previous one. Y equals to x cube plus 2x square plus 5x to the power minus 3. In the same way, I'm just giving the hint to you. You will assume that you let u equals to x cube plus 2x square plus 5x. Then your y will be u to the power minus 3. Got it? Just then you have to differentiate this thing, and then putting the value of u, you will get your final answer. You will solve this and tell me the final answer of this. I'm just keeping this for you students. Try this one, huh? Let us do the next question. Okay, the question number 3, y equals to square root over 1 plus x by 1 minus x. Again we can see that there is two things. One is square root, another one is this fraction function. in the form of rational function 1 plus x by 1 minus x. So similarly, in the same way, we can assume let u equals to 1 plus x. Simple. You have to always assume the function and you have to convert the given quotient into a known form, that is square root over u. This is similar to, like that we can say that this is similar to root over x. Here u, here x, and we know that ddx of root over x, in the last video also we have said that, just remember the result is 1 by 2 root over x. We will use the result, ddx of root over x is 1 by 2 root over x. So we will use this here. So first of all, we will differentiating both sides with respect to x, that is dy by dx equals to ddx of root over of u. That means what will use here, see there the result is ddx of root over x is 1 by 2 root x. So here root over y we can write 1 by 2 root over y, u, 1 by 2 root over u. But again this is u, this is x, they are not same. So by chain rule again we have to differentiate u. Should rub this. Okay, now putting the value of u, that is just putting the value of u. Now this part we will don't, this part will remain out of the differentiation. Now for this particular part, you can see that u by v form, that is division form, that is we can use here division rule. So will you use here division rule, that is after that we can write 1 by 2 root over, what was the 1 plus x by 1 minus x, and here the division rule. Denominator was, what was the denominator here, 1 minus x, denominator was 1 minus x, so we will write 1 minus x v square, then denominator ddx of numerator minus numerator ddx of, just check it, denominator. It is visible, na? That is after the next step, by 2 okay. Now this here the simple calculation part, 1 minus x, ddx of 1 0 plus ddx of x 1, 1 plus x, ddx of 1 0 minus ddx of x 1. Okay, here one plus x by 1 minus x, 1 minus x whole square, 0 plus 1 1, 1 into this, that is 1 minus x, 0 minus 1 minus 1 minus 1 minus, it become plus 1 plus x, and here plus x minus x will be going to cancel, 1 plus 1 2, so that is 2 by 1 minus x whole square. This 2 will be cancelled, so we can write in a combined form 1 plus x by 1 minus x into 1 minus x whole square. You can further simplify this thing also, that this term and this term we can simplify the powers, so that you can simplify or you can lift up to this also. So this is all about this question. This question was comes twice in last few years. So you can check this question also. This is one of the important question from your last years. Okay students, these are the three similar questions like the previous one. Same questions. For the first question you will assume we will here for you assume u equals to 2x plus 1 by x plus 2. Then your y will be root over of u. Same. In the same way, for this question also you will assume this question is important, huh? Try this question. This question is important. U equals to x square minus 1 by x square plus 1. Here also in the same way y will convert as root over of u. In this question also you will assume u as 3x plus 2 by 2x minus 5, and the y will be here u to the power 5. Same. Try these three questions. These three of the questions are homework for you. To total 4 questions till now I have given homework for you. So try that all the homeworks. So now let us try another different types of question from this topic of chain rule. Okay, question number 7. X equals to y log xy. Now before starting this question we will remember one property of log, that is log of a into b equals to log a plus log b. This is a property of a log, that is log of ab equals to log a plus log b. So if we use this property here, log of xy, so what we can write, log x plus log y. So we will use this property also here, that is log x plus log y, and this side x. Then we are going to open the brackets by multiplying y log x plus y log y. Now we have to differentiate both sides with respect to x. Differentiating both sides with respect to x, that is this side will be d dx of x and this side d dx of y log x plus d dx of y log y. Okay, d dx of x, we know that this is 1. Now here y and log x, that is two functions in form of multiplication, so we are going to use product rule. Product rule, that means at a time only one function is going to differentiate and another will remain out of the derivative. Now interchange their position, d dx of y. This is for the first term, plus now for this term. Now this term, what is was there, y log y. So we will again at a time only one function differentiate and another one will remain out of the derivative, plus now interchange log y dy by dx. Now y d dx of log x, formula number 3, d dx of log x is 1 by x plus log x dy by dx, no change for this part, plus y. Now here what is the term, d dx of log y. See students, here we have written d dx of log x is 1 by x, log x differentiation is 1 by x, so d dx of log y will be similarly 1 by y, same. But one thing to be noticed, here is our x, here is also x, both are same, so we have stopped the differentiation here only. But here this is y and this is x, these two are not same, so by the chain rule we will further differentiate y with respect to x. That is, I am saying we will again differentiate y with respect to x, and here log y dy by dx. Clear? Now just opening the brackets, here opening the bracket, y by x plus log x dy by dx plus here y and y cancel, dy by dx plus log y dy by dx. See students, we have to find dy by dx. Our target is that to find dy by dx. So what we'll do, we will take all the dy by dx terms together and the term which doesn't have dy by dx to the another side. So here we can see that y by x is that only term which doesn't contain dy by dx. So we will shift this term from right hand side to left hand side, that is 1 minus y by x. And in these three terms dy by dx is common, so we will take that common, and after that we will write from first term we will get log x, second term we get 1, and the last term we get log y. What do we have to find? Dy by dx, and this is in the form of multiplication. So this will shift from, if this term goes from this side to that side, so it is in the form of multiplication. Here will comes in the form of division. So finally your answer will be dy by dx. See, this is the multiplication, from here it will goes to that side, that means in the form of division it will go, that is 1 minus y by x log x plus 1 plus log y. Or we can, one more step we can simplify in this way, log x plus log y, that is we can write log xy. The first step of the question, log xy as log x plus log y. Similarly we are writing here log x plus log y as log of xy. So this is your final answer of dy by dx. Clear? So students, this is all about for today, this video lecture. This was the basic introduction for the chain rule of derivative. There will be a, this is a part 1 of the chain rule. That will be another, will be a part 2, that is an advanced one. They will do some higher level questions on this topic, chain rule. Up to this is all about the basic questions, how to understand, how to solve chain rule method, how to use the chain rule method, this is all about. And this is the 4 homework question for you. Just try this homework and wait for another part of this video lecture. So up to then, take care, stay at home, stay safe, goodbye.